Yes, good afternoon, students.
Good
Am I
afternoon, ma'am.
audible?
Yes, ma'am.
Harsh, Hitesh, am I audible, beta?
Yes, ma'am.
Okay,
Yes, ma'am.
okay, beta. And tell me, is my screen visible?
Yes, ma'am.
Yes, screen is visible to all of you.
Yes, ma'am.
Okay. Beta, today I'm taking this online class to discuss or to give an overview about the remaining topics of your syllabus, like sampling theorem, Fourier series, and the state space analysis. Okay. I think all of you have an idea what is sampling. Yes. What is sampling?
भेज देगी तुझे ना
Yes, beta. Anyone who can tell what is sampling? Like all of you know, there are two types of the signal, continuous and discrete. But generally, all the signals in nature is of analog type, or you can say continuous type. If you want to process the digital signal, then there is a need to convert continuous into discrete signal. Okay. The process which we use for this conversion is known as sampling. Sampling is nothing, it is the process of converting a continuous signal. Yes, you can see the screen. Yes, students. Aarti, Aarti, are you there
Yes,
in the class?
yes, ma'am.
Aarti. Okay, beta.
Yes, ma'am.
So sampling is the process of conversion of continuous signal into discrete, and this is done with the help of sampling theorem. Okay, this is sampling is the process of converting a continuous into discrete by measuring its amplitude, by measuring the amplitude of the continuous time signal at integer multiples of sampling interval. You can see by measuring the amplitude of this continuous, if this is the continuous given continuous signal and we have to convert it into discrete signal, then by using the sampling theorem we can obtain discrete version of the continuous signal by taking the samples of the continuous signal, by taking the samples and measuring the amplitude at particular instant of sample like ts and its integer multiple 2ts, 2ts, 3ts, 4ts. So converted version is x of nts, where n is the integer. So this process is known as sampling. Okay, and the condition which must be satisfied in order to represent xt in terms of its discrete or recovered back. All of you know, okay, we can convert continuous into discrete and we can also recover the signal from its discrete version. Okay, so that is the reverse process which is known as interpolation. So according to the sampling statement of the sampling theorem, band limited signal having finite energy, band limited means having no frequency components higher than the highest frequency present in the signal. Okay, having no frequency components higher than the frequency present in the signal, which is known as maximum frequency, or you can say highest frequency present in the signal. So this is the statement that any signal may be completely represented and recovered, may be completely represented and recovered from a knowledge of its samples if the sampling frequency is greater than and equal to twice of maximum frequency or highest frequency present in the signal. This is the condition which must be which must met for converting the signal from continuous to discrete and obtaining the signal back. So sampling frequency should be greater than and equal to twice of maximum frequency present in the signal. So this is the statement of sampling theorem. Signal may be represented and recovered back only when this condition is satisfied. Okay, so this is the statement of sampling theorem. And one, you should know what is Nyquist rate and what is Nyquist interval. As any signal is given to you like continuous, and if you have to find out its Nyquist rate and Nyquist interval, how you can find out? Actually, the Nyquist rate is the minimum sampling rate or minimum sampling frequency is referred to as Nyquist rate. When Fs becomes equals to twice of Fh, then the rate is known as Nyquist rate. Okay? When sampling frequency becomes equals to twice of maximum frequency present in the signal, then that rate is known as the Nyquist rate, and it's reciprocal. And its reciprocal is, what is the reciprocal of Fs? Yes, reciprocal of Fs is Ts. पता है how time is related to frequency? Yes, students? How time is related to frequency? Do you know? Achal, Bharat, Chirag, can you tell? बता सकते हैं how this time is related to this frequency? There is an inverse relationship exists between the time and the frequency. So this is known as Nyquist interval. How we can calculate the Nyquist rate and Nyquist interval of the any given signal. Okay, so this is how we can define minimum sampling rate, and its reciprocal is known as Nyquist interval. So how actually the signal is converted into this discrete version of the signal? This is the you can say the pictorial representation or graphical representation of the sampling theorem. Like this is the continuous signal, given continuous signal, and this is its Fourier transform. All of you know the Fourier transform is the transform which transforms time domain signal into its frequency domain. So this is the given xt and its Fourier transform x omega, and highest frequency is omega h. All of you know omega is 2 pi f. Okay, so xt and its frequency spectrum. Okay, this is the spectrum of xt, and this is the sampling signal. Sampling signal, which is the impulse train. You can see the train of impulse. All of you know the impulse signal, and this is the train of impulse signal and its Fourier transform. Fourier transform means spectrum of these impulse train. This is the st and this is s omega, time domain representation of the signal, and this is the frequency domain. And this is the sampled signal. And how we can obtain this sampled signal? By multiplying xt with this impulse train. Okay, given coming signal is the continuous. When this is multiplied by this impulse train of the pulses, then you can see you will get the sampled signal. Sampled signal whose amplitude is the impulse amplitude is the sample of the continuous signal at different sampling instant. You can see When this signal is multiplied by st, so the resulting signal is known as the sampled signal, and the amplitude of the impulses, you can see amplitude of the impulses is the samples of the continuous signal which are spaced at different integer multiple of sampling time. Okay, and this is the Fourier transform of this sampled signal. When you will mathematically calculate the Fourier transform of this sampled signal, then the graphical representation of the spectrum which you will obtain is this type, is the spectrum of the sampled, which you can see the shifted replica of the x omega, shifted replica of the x omega. This is the how graphical representation of sampling theorem. This like signal xt, which is having no frequency component higher than the maximum frequency present in the signal, and then the impulse train. This is the expression of impulse train st. Mathematically, how we can express impulse train. All of you know that we can express any signal in terms of the sum of impulses. Sum of impulses. So you can see this is the sum of impulses. This impulse train. Mathematically, we can express this impulse train as the sum of weighted shifted impulse, as the sum of weighted shifted impulses. So sampled signal, this is st, and when this st is multiplied by with xt, the sampled signal which you will obtain is x del t. When this original signal is multiplied by this st, then you will get xt and multiplied with st. So st mathematically you can put here like this, and this x del t is the impulse train with the amplitude of the impulses equals to the sample of xt at intervals spaced by ts. I have already told you how its amplitude is equals to xt. So this is the final mathematical expression of x del t, sampled version of the original signal. Okay, taking the Fourier transform of this and using the multiplication property of Fourier transform, the spectrum which you will get is 1 by 2 pi, and you can see this is the convolution, and convolution of any signal is multiplication of their Fourier transform. So multiplication of x omega and multiplication of s omega. So this is the Fourier which you will obtain spectrum of sampled signal. So Fourier transform of st is s omega. Fourier transform of st. When you will calculate the Fourier transform of this signal, which is s omega, then finally you will get this expression. Okay, and when you will put this expression of Fourier transform in this sampled signal, then you will get final expression of the sampled signal is you can see the convolution of both and convolution of the spectrum of original signal and the train or impulses spectrum, which is nothing. This is simply shift a signal x omega del of omega minus omega s, shifted signal of impulses, which is equals to x of omega minus omega s. The final expression which you will obtain for the spectrum of the sampled signal is 1 by ts n minus infinity to infinity x of omega minus n of omega s. So this is the proof of sampling theorem. Proof of sampling theorem. The Fourier transform is the spectrum of the original signal is the shifted replicas of the x omega. According to this mathematical expression, the final spectrum which you will obtain is the shifted replica of x omega at omega minus n of omega s. Means this is the final spectrum of the sampled signal. Okay, so this is statement and final proof of the sampling theorem. Okay, in terms of f, we can write x del f, x of f minus n of f s. So this is the statement, and this is how we can obtain this continuous discrete version of the continuous signal, proof of the sampling theorem. Okay, and in expanded version of this summation ko if we will expand, to you will get this form: x of omega plus 2 of omega x, x of omega plus omega as n is minus infinity to infinity. Okay, so in this way we can state and prove sampling theorem. The Fourier transform of the sampled signal is the infinite sum of the shifted version of the original signals, Fourier, which is scaled by 1 by Ts. So this type of spectrum you will obtain of the original signal using sampling theorem. So there are three cases arises, like the condition which must be satisfied in order to obtain the signal, in order to obtain the discrete signal from the continuous signal is fs must be greater than twice of maximum frequency present in the signal. So three cases are when this is greater, fs is greater than twice of fh, when fs is equals to twice of fs, and when fs is less than twice of maximum frequency present in the signal. So the exact signal which you can recover when fs is greater than twice of maximum frequency present in the signal. When this is condition satisfied, then there is no overlap between the shifted replica of x omega and the signal recovered exactly from its sampled version by means of a practical low pass filter with gain equals to sampling time and cutoff frequency omega c, which is greater than the frequency present in the signal. Okay, तो कोई भी discrete signal को we can convert into, we can obtain its original signal by passing through it low pass filter. Filter is an electronic device which is used for filtering the unwanted signal, or to which only pass the desired frequency of the signal and attenuate the unwanted frequencies, which is known as filter. And low pass filter is the filter which allows to pass only lower frequency of the signal and attenuate the higher frequencies present in the signal. If you want to recover original signal from the sampled version of the signal, means from discrete to continuous signal, that you can obtain by passing the signal through the low pass filter. And this whole process, this reverse process, is known as interpolation. Okay, this reverse process is known as interpolation, and which is done with the help of low pass filter. Filter is the device which allows to pass the desired frequencies and attenuate the unwanted frequency of the signal. Like the signal, original signal is the band limited signal, तो वी हैव टू पास द फ्रीक्वेंसीज अप टू कट ऑफ फ्रीक्वेंसी. तो हम ऐसी फ्रीक्वेंसी सेट करते हैं विच इज ग्रेटर देन द मैक्सिमम फ्रीक्वेंसी present in the signal. So when this is the case, so the signal you can obtain exactly from this sampled version. Okay, like xt is coming, st is coming, and their product say you will get the sampled signal, and from the sampled you can obtain the xt by passing it through the low pass filter. Okay, all of you know the convolution of these two is the multiplication of their Fourier transform. So when x del t का Fourier transform is x del omega multiplied by the impulse response of this low pass filter, then you will get the original signal. Like this is the spectrum of x del omega, okay, and this is the spectrum of impulse response of this low pass filter. Impulse response of low pass filter is means this is the rectangular impulse response having cut off frequency. यहाँ तक cut off frequency है बस. When this signal is multiplied by this one, when these two are multiplied, then you can see you will get the, यहाँ तक कट ऑफ फ्रीक्वेंसी है, अदर फ्रीक्वेंसीज विल क्या हो जाएंगी, अदर फ्रीक्वेंसीज विल अटेनुएट. तो the signal which you will get is x omega. x omega आपको क्या मिलेगा, बस up to the cut off frequency. तो shifted replica से you will get the original one by passing it through the low pass filter. And this whole process is the interpolation, and interpolation is only achieved when fs is greater than twice of fh. The exact recovery of continuous time signal from its samples by using low pass filter. Okay, so another case is when fs becomes equals to twice of fh. So there is no overlap between the shifted replica, and xt can be recovered exactly from x del t, again by passing it through the low pass filter having a cutoff frequency equals to the maximum frequency, and gain is sampling time. In this case the जो आपका shift impulse sampled आएगा, that there is no overlap but they will touch each other. The spectrum which you will obtain when fs is equals to twice of maximum frequency in the signal, so overlapping is not there, but you can see the spectrum, these are shifted. Spectrum means touch each other but not overlap. So in this case also we recover the signal from its sampled version by passing it through the low pass filter. But in the third case, when fs is less than twice of fs, when fs is less than twice of fh, then which is also known as undersampling. This condition is known as undersampling, aliasing, spectrum folding, all three we can say. Okay, when fs is less than twice of fm, then what happened, we will not recover xt from its sampled version by using low pass filter, and the x del omega which you will obtain is, you can see the overlap, you can see the overlap between the repeated spectrum of the signal. So this overlapping is known as the aliasing or spectrum folding. Okay, this overlapping is known as aliasing or spectrum folding. अगर ये होता है then it's very difficult to recover the original signal. So corrective measures for this aliasing or spectrum folding is either we can use pre-aliased low pass filter, which attenuates the higher frequency components present in the signal, which are not required for conveying the information. And second corrective measure is by considering fs is greater than and equals to twice of fm. Okay, fs condition, second condition is sampling frequency must be greater than and equals to twice of maximum frequency present in the signal, then only we can avoid this aliasing, spectrum folding or undersampling during the conversion process. Okay, so that is the condition of sampling theorem, and by using this, design of the reconstruction filter used to recover the original signal from its sample version become easy also. So these two are the corrective measures which we can use in order to avoid aliasing or spectrum folding, which may occur during the conversion process from discrete to continuous, or from continuous to discrete. Okay, so this is the statement of sampling, and how we can achieve sampling, its proof, and how we can recover signal back, which is known as the interpolation. So you should know how to calculate. All of you can see that there are two questions given on the screen, given Nyquist. You have to find out the Nyquist rate for these two given signals. दिख रहा है बेटा आपको? All of you note down these two part of the question for finding the Nyquist rate and Nyquist interval. Yes, you have to add this question in assignment number 2. Student? Yes, Deepak Kumar? Deepak Kumar? Dhruv Mishra?
Yes, ma'am.
बेटा क्वेश्चंस नोट कर लिए आपने? You have to add these two questions in
Yes,
the
ma'am.
assignment 2.
Yes, ma'am.
How to find out the Nyquist rate and Nyquist interval. And similarly, you can go through the other examples of the signals for finding the Nyquist rate and Nyquist interval. Okay? All of you note down these two questions.
Yes, ma'am.
कर लिया?
2 minutes, ma'am.
Okay.
मैम हो गया मैम.
Okay. This is interpolation. I already told you, and I'm also showing its type, and you have to go through in detail the interpolation. Okay. Reconstruction. Interpolation is nothing, it's reconstruction. Reconstruction is process of reconstructing a continuous time signal from its sampled version is known as interpolation. One of the method I have told you, what actually the interpolation, by passing it through. How we can obtain interpolation? By passing the sampled signal through a low pass filter. The reconstruction, and this can be done only when Fs is greater than or equals to twice of maximum frequency present in the signal. One thing for the reconstruction is important. One is frequency must be greater than and equals to twice of maximum frequency. Otherwise, the problem which may occur is aliasing or spectrum folding. Okay, and when this problem persists, then it's very difficult to reconstruct the signal. And this can be achieved or accomplished by using low pass filter. In the last, I told you how we can recover the signal Xt from its sampled by passing it through the filter. Actually, the filter attenuates the undesired frequencies and allow to pass only the frequencies which are desired. So the original signal you will get by passing through it low pass filter. So there are two types of the form of interpolation: zero order hold interpolation and first order hold interpolation. Zero order hold interpolation में the impulse response of the filter is of rectangular type, and in first order hold interpolation the impulse response of the filter HD is of triangular type. Okay, so this is the difference which exists between the zero order and first order. Interpolation is the same. For recovering the signal, we have to use ideal low pass filter. So there is small derivation for this zero order or first order go through that derivation. The basic process I have already told you what actually the interpolation, recovering the signal from its sampled version. Okay, so this is all about the sampling theorem and an interpolation. Clear? Yes, students, clear to everyone how you have to do sampling theorem? Its statement, its proof, numerical related to Nyquist rate and Nyquist interval, and interpolation means its reverse process for obtaining the signal. Clear? Yes, students?
Yes, ma'am.
Okay. Now I'm going to tell you, going to give you an overview about the Fourier series. Fourier series, again the transformation tool, Fourier transform, we had already discussed in the class, DTFT and CTFT, which is used for both periodic and non-periodic, but the Fourier series is the mathematical tool which is used only for periodic signal. Okay. Again, this is the transformation tool which transform time domain to frequency domain, but periodic signals go. Okay. So this is nothing. This is the representation of the periodic signal as the sum of harmonically related sinusoid. All of you know the periodic signal mathematically. We can write xt is equals to xt plus t, which is the periodic signal. When xt is equals to xt plus t, then the signal is known as periodic signal. We had already discussed in the class about the periodic and non-periodic signal. So Fourier series is the way of representation the periodic signal in terms of its sinusoid. Okay, and for Fourier series to exist, these three conditions must be satisfied, which are known as Dirichlet conditions. जैसे हमने Dirichlet conditions we had discussed for the Fourier transform. Similarly, there are the three conditions which must be satisfied for the existence of the Fourier series. So three conditions, which is if if the signal is discontinuous, there are a finite number of discontinuities in the period t. Second, it has a finite average value over the period t. Positive and negative maxima in this period. Okay, if these three conditions are satisfied, then only we can represent any signal using Fourier series, and these conditions are known as Dirichlet's condition for Fourier series. Okay, like Fourier transform, Fourier series may be of two types: CTFS, DTFS, continuous time Fourier series, discrete time Fourier series. So Fourier series can be represented in two ways: trigonometric Fourier series, all of you note down, trigonometric Fourier series and exponential Fourier series. तो किसी भी सिग्नल का, दिस इज द ट्रिग्नोमेट्रिक फोरियर सीरीज ऑफ द representation of the continuous signal xt. Here this is the CTFS, continuous time Fourier series representation of the signal xt is represented like this. This is the constant term and this is the term 1 to infinity. 0 pe you will get the constant, and 1 to infinity, this is the sum of harmonically related sinusoid. You can see an and bn are the coefficients. A0, an, bn are the trigonometric Fourier series coefficients. Okay, and these coefficients may be obtained like this. Agar if any periodic signal is given to you and you have to express that signal in terms of Fourier series, then you have to find out its coefficient, and you can find out its coefficient by using integral of these. Okay, and by putting the value of these coefficient in this representation, you can express any periodic signal in terms of trigonometric Fourier series. Okay, And exponential Fourier series is nothing. It is the another way of representation of trigonometric Fourier series. Can anybody tell how we can express exponential series using this trigonometric? All of you know. Yes? Anyone can tell how we can express this in terms of exponential?
मैम cos को e की पावर
Yeah,
मतलब
yeah.
एक्सपोनेंस में कन्वर्ट कर दिया
E j theta plus e raised to power minus j theta divide by 2. Similarly, e j theta minus e raised to power minus j divide by 2j. So by expressing cos and sine in terms of exponential, you will get exponential Fourier series. Okay. So कोई भी signal if given to you, you can express it in trigonometric as well. You can express it in exponential Fourier series. So you should know in Fourier series what are the Dirichlet conditions, what is trigonometric Fourier series, what is exponential Fourier series. If any periodic signal is given to you, how you can obtain this representation by finding out these coefficients a0, an, bn. Integration आपको पता होना चाहिए how to obtain the integration of cosine and sinusoidal signals. Okay, another point which is written in your syllabus is waveform symmetries. Waveform symmetries is exactly series may contain sine terms, cosine or both, which is the result of certain type of symmetry exhibited by the waveform. Means each waveform is having some symmetry which is known as waveform symmetry. Like knowledge of such symmetry basically reduced calculations in determining the Fourier series. What actually these symmetries done when we calculate when we want to find out the Fourier series, then the calculation reduced. How these calculation reduced, that you can see. Like all of you know about the even symmetry. पढ़ा है ना, even signals, odd signals. So these type of symmetries basically reduce the calculation in determining the Fourier series. Like all of you know, the even signal is the signal which is, yes, xt equals to x of minus t, having symmetry about the vertical signal. So when if any signal you can see, for example, this type of signal is even, and the functional values of t and minus t both equal. So even signal are the functions which are represented by the cosine terms. So sum of product of two even signal is even signal, and even signal is preserved. Nature of the signal is preserved. So you can see the signal xt is having even symmetry, which is symmetrical about the vertical axis. So when xt has an even symmetry, when any signal has an even symmetry, that the Fourier series coefficient are defined as it has two Fourier components, a0, an. In that case, bn becomes equals to 0. The Fourier series expansion of an even periodic signal contains only cosine term and constant. There is no need to calculate bn, as this becomes 0 for even symmetry. So calculation becomes easy in order to represent the signal in terms of its Fourier series. So where actually the waveform symmetries plays its role. Okay, so this is for the even symmetry. Means if the signal is even symmetry, then in that case bn becomes 0. You have to simply find out a0 and an. Okay, if xt is an odd signal having odd symmetry means when xt equals to minus of x of minus t, in that case these two becomes 0, a0 and an both becomes 0, and you have to calculate only this bn. Okay, for the odd symmetry, to reduce the calculation, these symmetries basically reduce the calculation during the representation of Fourier series. So during odd symmetry, these two become zero. Only the exist Fourier coefficient is Bn. There are two other symmetries also. One is known as the half wave symmetry, and half wave symmetry is when xt equals to minus of x t plus minus t by 2, minus of x t plus minus capital T by 2. So half wave symmetry means when this t increases from minus t by 2 to 2 is the negative of the waveform, with t increasing from 0 to plus t by 2. T minus t by 2 to 0 is the negative of the waveform, which is 0 to t by 2. So symmetry is known as half wave symmetry, and it contains only odd harmonics. It contains only odd. Even harmonics becomes 0. And the last symmetry, which is known as the quarter wave symmetry, this is the periodic signal when this possesses symmetry, when it has either odd or even symmetry, and second, it has half wave symmetry. Means when the signal is having half wave as well as either even or odd symmetry, then the symmetry is known as quarter wave. Okay, so quarter wave series to express or represent again becomes the calculation easy for finding out the coefficient. So this how the waveform symmetries plays and the types of waveform symmetries. यहाँ तक you have to done Fourier series. Okay. ना बेटा क्लियर है सैम्पलिंग थ्योरम एंड फूरियर सीरीज?
Yes, ma'am.
यस गीतिका, हितेश?
यस मैम, फूरियर सीरीज पूरा आएगा सैम्पलिंग के संग?
बेटा इस वाले सेकंड सेशनल में तो मैं नहीं दे रही. सेकंड, ऑल ऑफ यू नोट डाउन द सिलेबस ऑफ सेकंड सेशनल. अगर ये भी करना है तो थोड़ा सिलेबस ज्यादा हो जाएगा. बताओ करना है ये भी सैम्पलिंग और फोरियर सीरीज?
नहीं मैम, नो मैम,
No, ma'am.
नो मैम.
तो फिर सिलेबस नोट करो. डीएफटी में ओनली सर्कुलर कन्वोल्यूशन फॉर द सेशनल. ओके, circular convolution. We had discussed 3 methods for finding the circular convolution in the class.
Yes, ma'am.
क्या थे? हाँ, तो DFT में you have to do circular convolution. Then second topic is DTFT and CTFT. DTFT and CTFT. बेटे इनके साथ साथ हाउ टू ऑब्टेन इट्स इनवर्स ये भी आपको आना चाहिए. ठीक है, कोई भी फोरियर ट्रांसफॉर्म है या एनी ट्रांसफॉर्मेशन टूल, यू शुड नो हाउ टू कैलकुलेट इट्स इनवर्स ऑल्सो. ठीक है, इनवर्स के भी क्वेश्चन वी हैड ऑलरेडी डिस्कस्ड इन द क्लास. लाइक जेड ट्रांसफॉर्म है, उसका हाउ वी कैन ऑब्टेन इट्स इनवर्स. Laplace transform है, how we can obtain its inverse. Partial fraction we use for finding out the inverse of Laplace transform. And in case of Z transform, we had discussed 3 methods. Remember है? All of you remember those methods? याद है बेटा? लॉन्ग डिवीजन किया था, पार्शियल फ्रैक्शन किया था, कंटूर रेजिड्यू मेथड किया था. So you should also know how to calculate the inverse of the signal, inverse transformation. ठीक है, तो DTFT and CTFT. Third is Z transform complete with solution of difference equation, and fourth is Laplace transform.
मैम जेड ट्रांसफॉर्म पूरा आएगा मैम?
हाँ पूरा z ट्रांसफॉर्म कंप्लीट with its inverse, okay, and Laplace transform also. बेटा इनवर्स तो सभी का मेन भी आना चाहिए. हाउ टू ऑब्टेन इनवर्स मतलब हाउ टू ऑब्टेन डिस्क्रीट से कंटिन्यूअस बाय यूजिंग ट्रांसफॉर्मेशन सिग्नल, सॉरी टाइम डोमेन से फ्रीक्वेंसी एंड देन फ्रीक्वेंसी टू टाइम कैसे लेना है वो दोनों आने चाहिए. ठीक है. तो फर्स्ट हो गया आपका डीएफटी सर्कुलर कन्वोल्यूशन ओनली, डीटीएफटी सीटीएफटी कंप्लीट. इसमें भी सब बताया था. व्हाट आर द प्रॉपर्टीज, व्हाट इज द डेफिनेशन, हाउ इट एग्जिस्ट, व्हाट आर द इन्वर्जन, देन जेड ट्रांसफॉर्म, poles and zeros of Z transform, and solution of difference equation, and how to calculate the Z transform using properties also. ऐसे ही like Laplace transform, properties of Laplace transform, how to obtain the Laplace transform of simple standard signal, how to obtain Laplace transform of using properties, and then solution of differential equation using Laplace. ये सब आपको करना है और कॉजलिटी एंड स्टेबिलिटी की कंडीशन के साथ भी. ओके ये सब डिस्कस कर चुके हैं. वी हैड ऑलरेडी डिस्कस्ड ऑल इन द क्लास. आज सिर्फ वही टॉपिक लिए मैंने जो हमारी क्लास में नहीं कवर हुए थे.
मैम एक बार आप इनके नोट्स भेज सकते हैं मैम.
बेटा नोट्स तो मैंने पहले भी बोला अगर क्लास अटेंड करी है तो नोट्स एज सच चलो देख लूंगे, लेकिन फिर भी
मैम
अपना
भेज
कोई
दो
भी
प्लीज.
उठाना न्यूमेरिकल
भेज दो मैम
प्रैक्टिस
प्लीज.
मैम
और
प्लीज.
थ्योरी के साथ करो उसको प्रिपेयर. और
ma'am.
सेकंड असाइनमेंट नंबर 2 में यू हैव टू ऐड स्टेट स्पेस एनालिसिस. इम्पोर्टेंट ये आपको ऐड करना है. असाइनमेंट नंबर 2 में कुछ ही क्वेश्चंस थे. ठीक है. State space analysis means what actually the state space question लिखी है. What actually the state space analysis? What are the advantages of state space analysis? What is state transition matrix? What are the properties of state transition matrix? And state space analysis, numerical based on state space analysis. Okay, one or two example which you have to analyze using state space. तो ये आपका assignment number 2 है. Okay.
मैम एक बार हम एक बार वो बता रहे मैम सिलेबस. डीएफटी सर्कुलर कन्वोल्यूशन है मैम उसमें.
हाँ.
और डीटीएफटी एंड सीटीएफटी कंप्लीट है मैम.
हाँ. Z
जेड
transform.
इसके अंदर आपने कुछ बताए थे मैम, कुछ प्रॉपर्टीज वगैरह.
बेटा क्लास में जैसे करा था. व्हाट इज जेड ट्रांसफॉर्म, व्हाट इज आरओसी, प्रॉपर्टीज ऑफ आरओसी, प्रॉपर्टीज ऑफ जेड ट्रांसफॉर्म, एंड हाउ टू फाइंड आउट द ट्रांसफर फंक्शन, एनालिसिस ऑफ डिफरेंस इक्वेशन, है ना. और व्हाट आर द एप्लीकेशन ऑफ जेड ट्रांसफॉर्म. बेटा ये सब कवर हो चुका है. क्लास में सारे कराया भी था. तो आपको ये सब कवर करना है. हाउ टू टेक इनवर्स ऑफ यूजिंग जेड ट्रांसफॉर्म. उसके भी 3 मेथड थे. तो कोई भी आप अच्छे से मतलब तो ये पूरा कवर करना है. जेड और लाप्लास भी. जेड ट्रांसफॉर्म इज यूज्ड फॉर द सॉल्यूशन ऑफ डिफरेंस इक्वेशन एंड लाप्लास इज फॉर द सॉल्यूशन ऑफ डिफरेंशियल. तो आपको पता होना चाहिए हाउ टू एनालाइज डिफरेंस एंड डिफरेंशियल एंड हाउ टू कैलकुलेट द पोल्स एंड जीरोस. ये सब क्लास में कर लिया बेटा. जिसने मिस करी है उसे नहीं पता होंगे. बाकी तो सब डिस्कस किया हुआ है ना. तो ये आपका सेकंड सेशनल का सिलेबस है. बाकी फाइनल में तो यू हैव टू कवर ऑल द चैप्टर्स और ऑल द मॉड्यूल्स ऑफ योर सिलेबस. तो सारा सिलेबस ऑलमोस्ट आज कंप्लीट है. सिर्फ स्टेट स्पेस आपको असाइनमेंट देना है. स्टेट स्पेस असाइनमेंट नंबर 1 एंड असाइनमेंट नंबर 2 ऑफ स्टेट स्पेस. और मैंने आज एक क्वेश्चन दिया है वो. ठीक है. So these 2 assignment all of you will submit after sessional to your CR of your class, and CR will submit all the assignments to me. बाकी आपकी क्लास परफॉर्मेंस के मार्क्स तो मेरे पास है ही. एनी डाउट?
मैम फाइनल अटेंडेंस कब जाएगा आपकी तरफ से?
बेटा फाइनल बस कंपाइल हो रहे हैं।
मैम
बताओ।
तो कुछ अटेंडेंस रह गए थे ना, मतलब हम क्लब में बिजी थे, वहां पे आपने
बेटा
बोला था
तुम्हारी
कि लास्ट
मैम
में।
तो कह रही है जो कोऑर्डिनेटर है कि वो क्लब की वो ऐड करेंगी। हाँ
मैम आपने बोला था कि सीआर को भेज
मैंने
देना
बोला
लास्ट
था,
में।
लेकिन
यस मैम।
आपकी मेरी भी बात सुन लो बेटा। तुम्हारे जो कोऑर्डिनेटर हैं वो ये कह रहे थे कि क्लब वगैरह की वो ऐड करेंगी। एक बार गीतिका, गीतिका ये कौन सा दूसरा, हु इज अनदर सीआर, कौन है?
ma'am.
कार्तिक।
गीतिका बेटा अपनी मैम से कंफर्म कर लो कि हमें ऐड करनी है या वो ऐड करेंगे।
Okay, ma'am.
शायद वो ये लिख रहे थे मतलब कि वो ऐड करेंगी क्लब वगैरह, जो भी एक्स्ट्रा अटेंडेंस है जो करिकुलर एक्टिविटीज की है। अगर वो नहीं ऐड करेंगी तो मैं ऐड करूंगी ना। तो मैंने गीतिका तुम्हें बोला था सब बच्चों से ले लेना।
ओके मैम, एक बार हम उनसे कंफर्म करके आपको
तो एक बार
बताते हैं।
उनसे कंफर्म करो, फिर मुझे तुम गीतिका एक वो बना लेना शीट पर, किस किस की बाय चांस। वैसे तो तुम्हारी कोऑर्डिनेटर कह रहे थे वो ऐड करेंगे, फिर तुम्हें उनसे बात करनी पड़ेगी, है ना? तो
मैम
मुझे
आप कर
गीतिका
देते
तुम
तो ज्यादा
बताना
अच्छा।
बेटा, ठीक है?
ओके मैम।
अगर वो कहते हैं कि मैं ऐड करूंगी तो सब बच्चों को नहीं देनी पड़ेगी और उनको ही पास सबमिट होगी। अगर वो मना करती हैं फिर देखते हैं कि तुम कैसे रिकॉर्ड बना के मुझे भेजना है ना। एनी डाउट? अदरवाइज आई एम टेकिंग, नहीं तो आई एम टेकिंग अटेंडेंस। बताइए कुछ और पूछना है? इफ यू वांट टू आस्क समथिंग यू कैन आस्क राइट नाउ। नहीं तो क्लियर है बेटा, सिलेबस मेरी तरफ से ओवर हो गया आज।
हम डीटीएफटी और सीटीएफटी के इनवर्स वैसे निकालेंगे जैसे जेड इनवर्स
हाँ
निकाला था।
सिंपल से, हाँ बेटा उसको फार्मूले कराए थे।
यस मैम।
डीटीएफटी का उसका इनवर्स भी लिखवाया था, सीटीएफटी उसका इनवर्स भी लिखवाया था बेटा। सिंपल इंटीग्रेशन ही तो है।
यस मैम ठीक है।
उन्हीं के फार्मूले गिवन है कैसे डीटीएफटी से डायरेक्ट, और उसका इनवर्स, उसके इनवर्स फार्मूला से एक्सटी 1/2 पाई करके जो था, है ना?
एक्सक्यूज मी मैम।
हाँ बेटा।
मैम जो ट्रांसफॉर्मेशन के प्रॉपर्टीज है उनके प्रूफ्स भी करते हैं?
बेटा देखो, एक मैं प्रूफ ऑलमोस्ट सिमिलर होते हैं, लेकिन करने तो एक बार को सबके देखने पड़ेंगे। कुछ नहीं पता चलता कहाँ से कौन सा प्रूफ दे दिया जाएगा। जैसे लाप्लास तुमने करा कंटिन्यूअस है, वो सिमिलर टू होगा सीटीएफटी से, है ना? तो एक बार को उन थ्योरम्स के तुम्हें प्रूफ देखने ही पड़ेंगे, ठीक है? तो
मतलब
मैं
प्रूफ आ सकते हैं पेपर में?
हाँ बेटा आ सकते हैं, आते हैं, आ सकते नहीं। इफ यू विल सी योर प्रीवियस पेपर तो प्रूफ में कम। तो कुछ कुछ तो तुम्हारे में मेंशन्ड है, लाइक पार्सेवल्स थ्योरम मेंशन्ड है, मॉड्यूलेशन मेंशन्ड है, लेकिन एज सच इलेबोरेट सिलेबस इज नॉट देयर। तो फिर उस केस में आपको यू हैव टू गो थ्रू ऑल द प्रूफ वंस। ऑलमोस्ट सिमिलर टू ईच अदर है, लाइक इफ यू विल डू द लाप्लास सीटीएफटी में ऑलमोस्ट सेम प्रॉपर्टीज हैं बेटा, है ना?
ओके मैम।
तो एक बार को तो देख लेना, मैं सजेस्ट यही करूंगी, ऐसा नहीं है कि नहीं देखने हैं, ठीक है? तो अटेंडेंस
यस
प्लीज।
मैम।
तुमने रोल नंबर से तो ज्वाइन किया नहीं है।